With that, we got a basic introduction to testing components and services and when we inject services into components. But we haven't really talked about this async thing here. And our service thus far was synchronous. So there was no asynchronous task like we might have it when reaching out to a web server. Therefore, in the shared folder, I create a new service, the data service, and this service will now actually expose an asynchronous function which we want to test. So in here, I will also export this class, data service, and this should have a getDetails method. Now, getDetails will have a promise, the result promise, which is a new promise, and my IDE won't like promise here, so it will get red, but it will work, where we pass resolve and reject as arguments to the callback we're passing to the promise constructor. And then we basically set up a timeout which will expire after, let's say, let's make it 1.5 seconds. And here I want to execute another function, of course, where I simply resolve data. So I pass back a string holding data. And outside of this const of this promise, I will simply return this promise. So getDetails returns a promise, and this promise will resolve after 1.5 seconds. Now I want to test this. Back in the user component, which is where I want to use it, I will first provide the data service here. And I will set up a data property here to data, which of course is a string. And in the constructor, I want to inject it. So I will have my data service injected here so that the Angular 2 injector is able to do so. And keep in mind, we can always get the instance by accessing the injector as we did before. Well, back to the spec file here to write some tests. Thus far, we have tests using our user service, which is synchronous. Now I want to fetch my data asynchronously. So first, let's do a normal test and see if this works. But it probably won't work since I will name it. It shouldn't fetch data successfully if not called asynchronously. And this is not really a great test because here I'm testing features of the testing package and not of my app. But I want to show the difference between this way of setting up tests and using the async function here, which we'll use in a second. So right now we always pass the function as the second argument here. And inside of this callback, I would then execute my standard code, get access to my application here. And now I somehow need to access this getDetails method, which happens asynchronously. The thing is, I don't necessarily want to execute the real getDetails method, because this method might reach out to a server, and in a real application, you don't want to reach out to the server all the time when testing it. Instead, you kind of want to fake it. You want to override it. You want to create your fake implementation, which still is asynchronous, but does something else, or does at least not reach out and provide simply some dummy data the real service would also give you back. So therefore, I will create a new variable spy, and I will use spy on. And this is another function provided by the testing environment, so not an Angular 2 specific testing function. And here we first tell on what we want to spy. Well, the thing I want to spy on is the data service, which I can get access to, like I did here for the user service, by using the Angular 2 injector. So let's add it here. But now, of course, let's call it data service and get access to the data service. Add the data service import for that too. And then we use this data service to spy on the getDetails method there. You pass it as a string, but this name here has to match the method name you want to spy on. Well, with this set up, what I can do now is I can chain something with and then say return value. So we spy on, that means we get informed whenever getDetails gets executed. So this is what spy on means. We listen to it, and whenever it gets executed, when running a test, we won't execute it. Instead, we will return a value on our own. Now the value we will return here is promise resolve data. Now what this does behind the scenes is it will execute the code, the asynchronous code, but it will eventually give us back our own data and not what this asynchronous task would have given us. It will still run in an asynchronous fashion though. So what I can do here is I spy on it, I get this data, I can now run the change detection to update my component after I got this data here. And then I wanna check if this worked. So I will say expect, and I expect my app data field to be undefined. Normally, I would expect it to be something else, because in my user component, here in an ng-on init, I will now use my data service to get the details, and then, this is here a promise, then use the data I get back to set this data equal to the data I get back. That is what I would normally expect to happen. So that once this promise resolves, the data the promise passes me is stored in this data property. Here in the test, I'm saying that I expect it to be undefined. And the reason why I do expect it is because I know that this will kind of fail. And I will come back to this in a second. And before doing so, though, we should set data here of type string to avoid compilation errors. So if I now test this, we get success. And that means it does not give us the normally expected result. The normally expected result would be to get data, right? If I now write this, you will see it fails. The reason for that being that it indeed is undefined. So I'm just writing the other case to have a success test here. But undefined is not really what we would expect at runtime. We would expect data to be undefined at the beginning, but to be data, since this is what we return here, a string of name or of content data in the end. So how can we test such an asynchronous task where the state changes during the runtime? Let's write a second test for this. I will copy the first one here, but here I expect it, so it should fetch the data successfully if called asynchronously. And here I will generally use the same code. I will adjust it, but I will use the async function here. That function we're importing from the testing package, the Angular 2 testing package, and I will wrap my callback with that function here. Now what this does is it creates a kind of an asynchronous testing environment for Angular 2. It fakes it. It's not really asynchronous, but it allows us to run asynchronous tasks there. And Angular 2 is aware that there are asynchronous tasks and is able to handle them as if it would handle them in a real application context where they are indeed also asynchronous. To do this, I need to add one thing though. After detecting the changes, I need to use my fixture and execute when stable. This function on the fixture allows me to react to all asynchronous tasks are finished. So here I can then execute the then function of my promise, which takes a callback to be executed once it is done. And inside of this callback, I will expect something to happen. So once the asynchronous task has been finished, and there I expect it to be data. And now with that nested in there, I can now save this. And now we get 9 successful tests. Because now we're waiting for asynchronous tasks to finish. It's not really happening asynchronous. We're faking it here. Remember, we're returning our own value. But with async wrapping this callback, we're telling L2, hey, we do have some kind of asynchronous tasks, even though the promise resolves instantly, it still is a promise wrapping some value and not resolved or not the value itself. So with async, we're now able to call when stable here and wait for our environment to stabilize, for all asynchronous tasks to finish, and to therefore successfully access the data at the state it would be in a real environment. We do have an alternative to using this setup here. Since it kind of happens synchronously anyways and only theoretically is asynchronous, you noticed we didn't wait 1.5 seconds here. We can also copy this test, copy it down here, and call fake async, or use fake async as a wrapper. This needs to be imported from the Angular 2 testing package as well. What this allows me to do is, it allows me to get rid of the when stable function here, like this. So instead I execute expect and so on instantly, but I call tick in between. Now tick also needs to be imported from the Angular 2 testing package, and tick basically means in a fake asynchronous environment, finish all asynchronous tasks now. When tick is executed, asynchronous tasks are finished. We can finish them immediately since we resolve it immediately here. We don't wait 1.5 seconds. That is why we wrote it this way. We don't want to wait that time when testing. So we finish them immediately, and we should have access to the data. So let's see if this works if I save this. Indeed, we get a successful test here too, and this is how we now also use fake async. So you could use either async with this setup when stable and then in the callback your expectation, or fake async. It takes the same time, it's just a different philosophy. Here you more like fake or behave like it was really asynchronous, and here you just use tick to say, yeah, let's go on. This is how you can use services and components. I picked this task or these two building pieces as they are very important and probably amongst the most complex, especially with the injection and asynchronous tasks. I hope this was helpful. Again, I do have a document where you can dive a lot deeper into that. I want to finish this module by having a look at isolated and non-isolated testing cases. Let's have a look at this and learn what this is.